Hey everybody, so we are looking at our 3.1 video notes, and we're talking about system of equations. So the first definition that we need is just for a system of equations, and that is two or more equations that are being compared to each other I'm going to run out of room here, but they're being compared to each other, focusing on their type of intersection. I'm going to have to abbreviate that. So a solution to a system of equations is just the ordered pair or pairs that the equations share. Okay. And so we have a few different types of systems. So we have an independent pair where one or more points are in common. So one or more points in common. Okay. In other words, this is where we don't have infinite solutions, right? We have one solution. So that would look on a graph. We have two lines and they intersect at one point. Okay. Dependent would have infinitely many solutions or infinite solutions because they're overlapping lines, right? So here's one line in black, here's one line in red, right? They're overlapping, so they share all of those points along the line. And then our final kind is an inconsistent system, which is our line that has no solution, which would be a parallel line, a set of parallel lines, because these parallel lines, they can go on infinitely. They go on infinitely in each direction, and they're never going to intersect, right? They're never going to intersect at any point, so they have no solution. So if we look at our examples, we're determining if the coordinates that we're given are solutions to the system of equations below. So I'm just going to plug in the coordinate that I'm given, which is 4, -1. I'm just going to plug it into each of these equations, right? So y plus 5 equals 2 times x minus 2. I'm just going to plug in -1 plus 5, right? And that -1 comes from our ordered pair up here, equals 2 parentheses 4 minus 2. That's going to end up simplifying to 4 equals 2 times 2. 4 does in fact equal 4. So that top equation works, right? This works for us. Now if I try to plug that in to my other equation of y equals -1/4 x minus 1, I end up getting -1 equals -1/4 times 4 minus 1. And just with our algebra, we end up with -1 equals -1 minus 1, and -1 equals -2. That does not work. And therefore, because that point 4 -1 does not work for our second equation, we can say that 4 -1 is not a solution to the system Okay, so same process for letter B. We have our ordered pair of -1 or -1/2 comma 3. So if we plug it in to our first equation, we get 3 equals 2 times -1/2 minus 2, which gives us 3 equals -1 minus 2, 3 equals -3. So we don't even need to plug it into that second equation because we know right away that 3 does not equal -3. So this top equation doesn't work, and therefore -1/2 comma 3 is not a solution to the system. Okay. So let's look at an example in graph form. So we're given a graph over here to the right where we have temperature on our y-axis and the time of year in spring on our x-axis. And we're given two cities. We're given Rio de Janeiro, which is in Brazil, and we're given San Francisco, which is in California. And so the first thing that we're answering is, what does the graph represent? Well, we're measuring the change in we're measuring the change in temperature over time, right? So so the graph represents the change, and sorry if you hear a dog barking, that's my neighbor's dog. The change in temperature in the spring for San Francisco and Rio de Janeiro, which are two cities on different sides of the equator. So different sides of the equator. Okay, so the intersection, so this point where the two lines meet, what does that represent? That's the point where the intersection represents the time in spring where the temperature in Rio and San Francisco is the same. Okay, so that purple dot right here where these two lines intersect is the time in the spring where the temperatures in those two cities are the same. Okay, so we're going to combine these two things, right? We're going to combine our checking for solutions and graphing to solve systems of equations by graphing. Okay, so step one in this, and you can see this play out in the graph below down here, is to graph all of the points of this first equation, right? So we graphed our points of 2x minus 5, which is this line here. And I know that just by looking because my y-intercept is -5. And then my second equation is x minus 2, which is right here. And again, I know that because my y-intercept is -2. Okay. You only have, what number 2 says is plot the second line, but only the necessary points. You can see that play out here. You don't need to like keep graphing each of these points until you reach the end of the graph. You're just graphing a couple of points beyond where the two lines intersect, and then you're determining the point where the two lines intersect, which in this case is going to be right here. And that point is 3, 1. Okay. And so And so we know that our solution is the ordered pair 3, 1, because that's where the two lines intersect. I just want to note here, up here it says for the best accuracy, plot the lines from slope-intercept or point-slope form. Do not plot directly from standard form. So if you get an equation in standard form, you want to convert it to slope-intercept form. Okay. So let's try examples 3a and 3b. So first things first, we're going to graph our first equation, and we have just, again, this is simple kind of review stuff of slope-intercept form. So we know our slope is 2, and we know our y-intercept is 3. Rather, -3, my apologies. And so I'm just going to graph that, right? So I have my y-intercept of -3, and I'm just going to graph my slope up 2 over 1, 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 okay? And then down 2 over 1, down 2 over 1, oops. Rather, down 2 over 1, down 2 over 1. Okay, so there's my first line. And then I'm going to graph my second line. So my slope is -1/3. Y-intercept is +4. So 1, 2, 3, 4. And remember, I only need to graph as many points as necessary to get to the point where they intersect. So I'm going to go down 1 over 1, 2, 3, down 1 over 1, 2, 3. And that's all I really need to graph, because I can see at that point that right here is where they intersect. And that point is 3, 3. And that's my solution. It's the point of intersection. So for letter B, I'm going to do the same thing. First equation, and we'll keep it black just for consistency. Our slope is 2/3. Our y-intercept is -1. So I'm going to plot my point at -1, and then walk my slope up 1, 2 over 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Okay. Then down 2 over 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And then we can just connect them. Okay. And then we're going to graph our second system, but and this is in point slope form. So if we just recall from our point slope formula, our slope is going to be 2, and we don't have a y-intercept, but rather we have a point, which is going to be 3, -3, and that comes from 3 and -3. So I'm just going to plot that as well. So if I go 1, 2, 3, 1, 2, 3, and then I'm just going to walk my slope, right? 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. There's my point of intersection where the two lines meet. I'm just going to walk the slope one more time. And I'm going to draw my second line. I'm going to circle where my 2 points meet, which is at 6, 3, and that's my solution. Okay, so it's a couple of steps. You're graphing a couple of lines, which you know how to do already. You're doing that using slope intercept form or point slope form, which again you know how to do already. And then you are seeing where the two lines intersect, where they meet, and that's your solution. Okay. So for letter C, we're going to want to convert the second equation. We can first graph our first equation. So we have a slope of -3/2, or -3/2, and we have a y-intercept of 5. So I'm going to go 1, 2, 3, 4, 5, and then I'm just going to walk my slope of -3/2. So 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, and I think I can do one more. 1, 2, 3, 1, 2, and then 1, 2, 3/2, and that's all I can do for that one. Wow, that was off. Holy cow. Let's try that again. Okay. And then for my second equation, 3x plus 2y equals -8. This is in standard form, so which might look a little intimidating. We haven't done it in a little while, but remember, you're just focusing on getting y by itself. So how do we do that? We're going to subtract 3x from both sides. So we get, let me fix that 3 for you. So we get 2y equals -3x minus 8. We're just going to divide the whole thing by 2, and we end up with y equals -3/2 x minus 4. And now we have the information we need to graph it, because we have a slope of -3/2 and a y-intercept of -4. So I'm just going to graph that, -1, 2, 3, 4, and I'll walk my slope of -3/2. So down 1, 2, 3 over 1, 2, 1, 2, 3 over 1, 2. Walk up, we go 1, 2, 3 over 1, 2. And it's clear now, as we connect, that we've got a set of parallel lines, right? Let me erase, well, right? So we have a set of parallel lines, which means these 2 points never intersect, which means that they have no solution. Now, I did all of that work, but if we look back, we actually see that both equations have a slope of -3/2. And when we have 2 equations with an equivalent slope, with the same slope, we know that those are going to be parallel lines, right? So we could have kind of predicted that from the start. And I'm just going to note that these 2 sort of forward slashes stands for parallel. So parallel lines, because they have the same slope. And because they're parallel lines, there is no solution. So let's look at letter D. So our first equation is in standard form. We have x plus y equals -4. We want to get y by itself. So we're going to subtract x from both sides, and we get y equals -x minus 4. which means our slope is -1, and our y-intercept is -4. And then our second equation is in point slope form. So we can pull the slope out as 2, that comes from there. And our point is going to be 2, -3. And that comes from 2, -3. Okay. So then we're just going to we're going to plot our plot our equations, right? So our first one in black over here is a y-intercept of -4 with a slope of -1. So just down 1, over 1, down 1, over 1, down 1, over 1. I know it's tedious to graph each of these points, but you gotta do it. Okay, easy enough. Connect my line, and then I'm gonna plot this graph as well. So our point is 2, -3, and we have a slope of 2. So I'm gonna go, I know I'm gonna intersect at some point down below, so I'm actually gonna graph downwards first. So I'm gonna walk my slope down 2 over 1, down 2 over 1. Then I'll go on the other side up 2 over 1. And then we can just connect. We see right here is where our two lines intersect, and that is at the point 1, -5, which is our solution. Okay. Looking at letter E, so once again we have one of our equations is in standard form, so we're just going to have to isolate the y. So we're going to add 3x to both sides. We get 3y equals 3x plus 12. We'll divide our whole thing by 3, and we get y equals x plus 4, which means our slope is 1 and our y-intercept is 4. And then with our other equation, we can just pull the information. Our slope is -2 and our y-intercept is also -2. So let's just plot out our graphs. Go black first. So our y-intercept is +4 and our slope is 1. Sorry, I just had like a panic attack. I lost sight of my Screencastify. I thought I had stopped recording for a second. Okay, so we're plotting our points. So our slope is up 1 over 1. We'll do that on the other side. Okay, and then we'll plot our other graph. So our y-intercept is at -2, and we're just going to walk our slope. We'll go up 2 over 1, up 2 over 1. I see that's where we intersect. So I'm just going to do that one more time. Connect. Here's our point of intersection at -2, 2. And there's our solution. Last one, letter F. So our first one is in point slope form. So I can just pull out my slope is 3/4, and my point or my ordered pair is 8, 9. For the second equation, I do have to convert it from standard form to slope-intercept form. So 6x minus 8y equals negative 24. I will subtract 6x, and I get negative 8y equals negative 6x minus 24. Divide by negative 8, and I end up with y equals 3/4 x plus 3. So my slope is 3/4. My y-intercept is 3. And let's just do some graphing. So plotting a point at 8, 9. So we walk it over to 8 to 9. And I'm just going to graph downwards from down 1, 2, 3 over 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And that's all I can do for that line. Now in red, our y-intercept is positive 3. And we shall see as I walk my slope that these lines actually overlap. Which means what? It means that we have infinitely many solutions because they always, each point intersects. There are infinite intersection points. Okay. This next page is going to ask you to graph using your TI Nspire. So why don't you read through the directions, and I'm just going to give you the answers to these equation sets, and you can check your work for that. Okay, so for A, you should have gotten negative 2.73 comma 3.18. For B, you should have gotten 1.32 comma negative 0.15. And then for these last two, you should have gotten no solution. All right, as always, let us know if you have any questions. I'm actually going to kind of go rogue and say I'm going to put a question at the end of this Edpuzzle that if there are any specific examples that you want to go over, let us know so we can help you out with that. All right. And